derivatives of trigonometric functions. And the two main ones are sine and cosine, because with trigonometric functions, you can convert any trigonometric combination into sine and cosine, okay? But we do have all of the derivatives right here, all the rules right here for all of the different the 6 basic trigonometric functions. But then there's also these two things right here that we just, that they say, okay, that they use to show, how to take the derivative of the sine and the cosine. So the limit as theta goes to 0, sine theta over theta is 1, and limit as theta goes to 0, cosine theta minus 1 over theta is 0. You notice that if you just try to plug the 0 in, here you get 0 over 0. If you try to plug 0 in here, you also get 0 over 0, because cosine 0 is 1. So 1 minus 1, that's 0, and then this is also 0. But this limit is 0, and this limit is 1. Okay, so let me just show you how you would try to take the derivative of sine x, for example. Okay, so this is going to be the limit as h goes to 0 of sine of x plus h minus sine x. Okay, that's f of x plus h minus f of x all over h. Now, what you do now is you use the sum rule here, sine of x plus h, and you can look that up if you want. I'm not going to require you to memorize those, but it's the sine of a plus b basically. But in this case it's x plus h, so that's just the sine of x cosine h plus cosine x sine h. Okay, that's all this right here. It's just the addition of angles formula, and then all that is minus sine x, and all that's over h. Now the key here is to play into this and this, to use these two facts right here. And so the first one would be you take this term and this term, and just look at those. They'll both have a sine x in them, right? Okay, they both have a sine x. So you're going to factor that sine x out, and you're left with cosine h minus 1. Okay, and then that's all over h. And then the next key is to take this one right here by itself. And so you have all that. Okay, now we can play into both of these. So if you look at this one right here, this is cosine theta minus 1 over theta as theta goes to 0. Here we have, if you ignore that for now, you have cosine h minus 1 over h as h goes to 0. Okay, so this theta could be replaced with an h, and this would still be true. The limit is going to be 0. So basically what that is saying is that all of this, it's basically the same thing as this. So that's just going to go to 0. And also, this right here is basically just this. As the limit as h goes to 0 of this. And that's going to go to 1. So in the end, since that goes to 0 and then 0 times sine x and the whole thing goes to 0, since that goes to 1 and it's times cosine x, then it's cosine x. Okay, so that's cosine x. So the derivative of the sine is the cosine, and that's this formula right here. Now you could do the same thing with the cosine, where a similar thing will happen, and you'll get negative sine x. Okay, now tangents can be different, but what you would do for a tangent is, like for example, you would rewrite the tangent as the sine over the cosine, and then use the quotient rule. And that's basically what you would do with all of these. Just rewrite them as quotients and then use the quotient rule.
I just have a quick question. Can you explain again why sine theta over theta equals 1 and why cosine theta minus 1 over theta equals 0?
Well, well, the book says that it's on the basis of numerical and graphical evidence. Basically, the way to prove this is beyond the scope of what we want to, or where we want to go. But the book just says based on graphical and numerical evidence, those are the limits.
Okay, that's fine. Thank you.
Okay. So that's not really something that you need to know at this point. Okay. So those are the basic, the derivatives of the trigonometric functions. There's all 6 of them are there. Let's go ahead and get in on the homework. Okay, so number 1, find the derivative of this function. So it's t cosine t plus t squared sine t. So you're going to use the product rule. So it'll be, so this one will be t, so the first function, multiplied by the derivative of the second one. And the derivative of this is, the derivative of the cosine is negative sine. Okay, and they've got x's here, but these are t's, so just use t's. Plus the derivative of the first one times the second. Okay, so that gives me those 2 terms. And then this one gives me 2 terms as well. So that's t squared times the derivative of the second part, which is cosine t. A derivative of sine is cosine. Plus the derivative of t squared, which is 2t times sine t. Okay. So in the end, we have negative t sine t plus 2t sine t, and that's gonna, those 2 are gonna combine to give you t sine t. This is cosine t, and this is t squared cosine t.
Sorry, can you explain that step right there? How did you combine t negative sine t with 2t sine t?
Yeah, of course. Oh, okay. Oh, yeah, of course I can explain that. So this and this is going to be negative t sine t plus 2t sine t. Okay, so if you factor a t sine t out, you get negative 1 plus 2. And then negative 1 plus 2, of course, is just 1. And so so you end up with t sine t right there.
Okay, perfect. Thank you.
Okay. So it's just like if you had negative x plus 2x. That's going to be x. Okay. So let's take a look at number 2. We want to differentiate this. And we can use the quotient rule. Okay. So y prime is, okay, so by the quotient rule, it's low, so the bottom one, times the derivative of d high, or the derivative of the top one, which is 4, minus the top one times the derivative of the bottom one. Okay, so the derivative down here is, the derivative of 7 is just 0. And then we have negative tangent x. Okay, the derivative of tangent is secant squared. So the derivative of negative tangent would be negative secant squared. Okay.
So when you're taking the negative of a derivative, is it just like, do you just do the derivative and then multiply it by -1?
Yeah. Yeah, that's when you multiply by a constant. If it's another function, then that's a different story. Okay, all over the square of what's below. Like that. Okay, now I should probably multiply everything out in the numerator, so it's just not so cluttered up. So distribute the 4 in, that's 28 minus 4 tangent x. And then you have a minus and a minus. This zeros goes away, so minus and minus, so that's going to be plus 4x secant squared of x. All over 7 minus tangent x squared. Okay, and then that should work for the answer. Okay. Number 3, find an equation of the tangent line to the graph at the point 0, 6. Okay, so first of all, if you plug in, so this is setting t equal to 0, you should get 6. And indeed, if we take f of 0, see there's f, so f of 0 will be 6 e to the 0 cosine of 0. Now e to the 0 and cosine 0 are both 1, so that's just going to be 6. So basically that point is on the curve. Okay, now let's go ahead and find the derivative of this. Okay. Okay, so it's a product. You can consider it as the product of 6 e to the x times cosine x. Okay. So it's the first one times the derivative of the second one. The derivative of cosine is negative sine. Plus the derivative of the first one, which is 6 e to the x, times the second one. Like that. Okay, so f prime of x is negative 6 e to the x sine x plus 6 e to the x cosine x. Now, we want to find the equation of the tangent line. That means we're going to set x equal to 0, should be x. So f prime of 0 would be negative 6 e to the 0 sine 0 plus 6 e to the 0 cosine 0. Okay, sine 0 is 0, so that goes away. And then e to the 0 and cosine 0 are both 1, so that's just going to be 6. Okay, so that means that the slope of this tangent line, which the slope is the derivative, the slope is going to be 6. Okay, so we have y equals 6x plus b. But we also know that it goes through that point, 0, 6. So plug a 6 in for y and a 0 in for x. and you have b is also 6. And so the equation is y equals 6x plus 6. Yeah, if there's any questions, just let me know. Okay, let's take a look at number 4. Find f prime. So here we have this function here. Find f prime in 2 ways. First, by using the quotient rule, and second, simplifying the expression by writing in terms of sine x and cosine x. Okay, so first we're going to use the quotient rule. There's a quotient rule. So we're using the quotient rule. Okay. F prime of x is, okay, so here we have again. So we have low, which is secant x, d high. So the derivative of that, the derivative of tangent is secant squared. And the derivative of this constants are 0. So that's minus 0. Okay, then minus high, which is tangent x minus 1, d low. So the derivative of secant, and when we look up here, the derivative of secant is secant x, tangent x. And then you're dividing by the square of what's below. So you're dividing by secant squared x. Okay, now you notice that there's basically 3 terms. There's this term, and then there's that term there. Okay, each of those has a secant. Okay, so if we factor that out, it will cancel with one of those secants. Okay, so we end up with secant squared x. And then over here, if we distribute the tangent in, we have minus tangent squared x plus tangent x. Okay, so tangent, this time this is tangent squared, but it's minus. This time this is negative tangent x, but there's another minus, so it's plus. And then all that's going to be divided by secant x. Okay, so you can put that in for the first answer. Okay, now for the second answer. Second is by simplifying the expression first and write it in terms of sine x and cosine x. Okay, so tangent x is sine x over cosine x, and secant x is 1 over cosine x. So this is a complex fraction, but if you look at that term, and that term, the common denominator is cosine x. So this is not too bad to deal with. So you multiply by that, by this 1, this fancy form of 1. Okay, then when this times this is just 1. Up in the numerator, you've got cosine times this, that's just going to be sine x. And then cosine times 1, that's minus cosine x. So you have sine x minus cosine x. So all this simplified to sine x minus cosine x. And now the derivative. Okay, derivative of sine is cosine. And the derivative of cosine is negative sine x, but you have the negative here, so it's going to be plus sine x. Okay, so that's the answer to the second part. Are those answers the same? Well, of course they're going to be the same. I guess this is much simpler than that, right? So what we would probably want to do is go ahead and try to simplify this and see if we come up with that, okay? So I guess that we can rewrite all these in terms of sines and cosines. This is 1 over cosine squared x minus sine squared x over cosine squared x plus sine x over cosine x. And then secant is 1 over cosine x. Okay, so probably if you look at all these terms, there's cosine squared, cosine squared, cosine, cosine. So cosine squared x is the common denominator to each of those parts. And we're running low in space. I'll come up here. Okay, so distribute that in there. You're going to get 1 minus sine squared x, and then plus sine x cosine x. Oh dear. Okay, and all that's divided by cosine. By cosine squared times 1 over cosine is just cosine x. Okay, now one important trigonometric identity is that sine squared plus cosine squared x equals 1. So that means that 1 minus sine squared is cosine squared. This is cosine squared x. And then you factor a cosine x out. You have the numerator. And then those cancel, and you end up with cosine x plus sine x. And those end up being the same. Okay. So a lot of times it's easier just to translate, to change these trigonometric functions into sine and cosine when you have something complicated like that, because I think it was easier to take the derivative here than it was to do the numerator, than to do this first way.
So was that trying to prove also in the beginning? We were talking about there's one where we multiplied f of x and g of x first, and then we took the derivative of that, and it was the same thing as taking the derivative of f of x times g of x. Like instead of doing the quotient rule,
that's really similar. That's a similar issue. So sometimes the product rule makes things harder, or the quotient rule could make things harder for you to do.
So are we?
But yeah,
go ahead.
That's sort of a really similar issue. So sometimes doing it one way is easier than another way. So a lot of times the quotient rule makes it easier. Sometimes it makes it harder to do.
So will it always hold true that you can multiply the functions together first and then take the derivative of that?
Yeah.
Product? Okay.
But sometimes it's not possible. See, like for example, like right here. I mean, you can't multiply those together. But if you have like 2 polynomials, then you can multiply those together.
I see.
But then, you know, it might not be worth it. It might be easier to use the product rule.
Okay. Thank you.
Sure. Okay, number 5. A 20-foot long ladder rests along a vertical wall. Let theta be the angle between the top of the ladder and the wall, and x be the distance from the bottom of the ladder to the wall. Okay. If the bottom, so let's draw a picture of that first. Okay, so we have the ground here, and then we have this wall here, and then we have this ladder. Okay, there's a ladder right there. Theta is the angle between the top of the ladder and the wall. So theta is going to be this angle here. X is the distance from the bottom of the ladder. Here's the bottom of the ladder to the wall. So that's going to be X right there. Okay, the bottom of the ladder is sliding away from the wall. Whoa. I hope someone's not standing on the ladder up here. That would be really bad. Okay, if the bottom of the ladder slides away from the wall, how fast does X change with respect to theta when theta is pi over 3? Okay, so The ladder is, okay, I forgot one thing. The ladder is 20 feet long, so this is 20, right? Okay, so our theta, x, and 20 are related by this formula here. So theta is, wait, the sine of theta is x over 20. Okay, so here's theta. The sine is the opposite over the hypotenuse. So sine of theta is x over 20. They're related in this way. Okay, so that means that x is equal to 20 sine theta. Okay, now dx dt, or dx d theta, is 20 cosine theta. Okay, so it's saying how fast does x change with respect to theta? So the how fast x change with respect to theta, that is dx d theta. Okay, when theta is pi over 3. Okay, so dx d theta, when theta is pi over 3 is equal to 20 cosine of pi over 3. Okay, now if your angle is pi over 3, that's pi over 3. Then this is 1, that's 2, that's root 3. So cosine of pi over 3 would be 1 over 2. That's adjacent over the hypotenuse. That's 1/2. So the answer is going to be 10. 10 feet per radian, according to the answer in the book in the Webassign. Okay, number 6. Finding this limit. Okay, so remember we started off by saying, okay, just take these two limits for granted, and I'm going to show you how you can use them to find this, particularly the first one. So you have tangent over sine, right? It's a tangent of 12t over sine 3t. So first of all, you can write the tangent as sine 12t over cosine of 12t. Okay, and then you have 1 over sine 3t. Okay, now here's where it's a little bit tricky. But this one, you could also say, this also implies that if you had, let's say, a, some constant, a positive number a times t, if you had like sine of at over at, that would also be 1. As long as, so the key is that this and this have to be the same, just as that and that are the same. But if you multiply by a positive number, then they're good. Or if you multiply, even if you multiply by a negative number, then you're good too. Okay, and then also, because if the limit's 1, then also, if you had it the other way around, that's also going to be limit 1, because this is just the reciprocal of this one, and this is 1, so that's 1. Okay, so with that information, that's not really what we have, but you can easily make it that way. We just say, okay, I wish there was a 12t down below. Yay, your wish is granted by the all-powerful genie. And there's a 12t right there. Yay. And then this one, you could be like, I wish there was a 3t up above it. There you go. There's a 3t right there. Okay. And then there's also this, you're still left with this cosine of 12t. But then with all of these kind of wishes, there's always a price that you have to pay. But the price is not too bad. The price is over here. So, okay, this obviously is not equal to that because we got these extra terms, right? We have, particularly have that term and that term, right? But if we just put a 4 right there, then we're fine. Because now 4 times 3t is 12t, and those would just like reduce off. So those are fine. Okay, now this one, as t goes to 0, that goes to 1. That also goes to 1. Put a 1 in there, cosine of 0 is 1, so that's 1 also. And we just end up with 4 as the answer.
Wait, sorry, where did the 4 over 1 come from?
That, I put that there so that all of this, would be equal to all of that. Since the difference is I added that and I added that. Now the t's will cancel, so they're fine. 12 divided by 3 is 4, but you'll have a 4 down here. That's extra, so I just put a 4 right there to balance it out. Okay, so let's look at number 6. This is going to be a similar thing. The limit as theta goes to 0 of cosine theta minus 1 over sine theta. Okay, so we have cosine theta minus 1 over theta. The lat limit is 0, right? But this is over sine theta. So it's a similar thing. We're just wishful thinking. Look, I wish that there was a theta here. Yay, there you go. Okay, now I know that limit's going to be 0, right? But this is not equal to that. But I can make them equal by just multiplying by that. Now they're equal because the thetas are going to cancel. So this is equal to that. Okay, so that is exactly equal to that because the thetas are going to cancel. Okay, now the reason I did that is because now this limit here is just going to be 0. And this limit, this is the reciprocal of this, so that's just going to be 1. Okay, so the answer here is going to be 0. Okay. Any questions with that? Okay, let's do this one right here. Okay, let's see. Okay, this is the 107th derivative. Whoa, have you guys ever taken that many derivatives? 170, the 170th derivative, 107th derivative, ouch. Okay, so well, let's just start with the first derivative. Here's the first one. That's cosine x. And then let's do this. Okay, let's go. Let's let f of x be sine x, and then that's f prime of x. The second derivative. So that would mean this that this is the 107th derivative of x. Okay, second derivative is going to be, okay, derivative of cosine is negative sine, right? And then the third derivative, this is 3. Usually you put 3 primes, but since we're going to be going all 107, then I'm just going to put a 3. Okay, derivative of sine is cosine, so that's negative cosine. And then we have the fourth derivative. And the fourth derivative, okay, the derivative of cosine is negative sine, but there's a negative there, so that's going to be positive sine x. And so the interesting thing is we're back at sine x. So after 4 derivatives, we're back at sine x. If we do another 4 derivatives, okay, so we're at the 8th derivative, and that's also going to be sine x. Okay, so everything, any order of derivative that's divisible by 4 is going to be sine x. So we're going to do 107 derivatives. What's the largest number that's less than 107 that's divisible by 4?
$104.
Yeah, 104. Okay, so that's going to be sine x. So that means you go 3 more. That means that this is going to be the same as the third derivative, which is this one right here. So negative cosine x.